Right. So can you hear me okay? I guess you can hear me. I hope you can hear me. Right. Okay, so this work is, it was conducted by me and William Young, who's sitting back there typing up something. And both, no, it's not sleeping, he's okay. So it was done in cooperation with some top-notch kids from the TOSCA technical committee. And myself, I was not really a big fan of TOSCA when I first walked into it, so I'll also show you why and why I actually changed my mind eventually. That's why it's Frank-centric, because Frank is really much inside this. But it's Wolfgang's, so I stole it from Wolfgang's slides this morning. Okay, so what am I up to today? I will show you DevOps in very brief terms, and also how TOSCA fits into what DevOps is about. And then the research problem and scope that I actually tried to explore with these kids from the technical committee, and what came out of it, so what is known as intent modeling that I myself don't really understand yet fully, and I'm trying to look into it, so maybe together we can actually do some more looking into it together. And then some mind-blowing future works and conclusions, right? Okay, so first things first, what is DevOps? I guess all of you have heard of it. I mean, it's SummerSOC, so DevOps was probably born here in some respect. Well, it's basically a series of practices, and there's really nothing new. It's a series of practices to accelerate the lead time from development to operations of certain features, right? So its goal is to also create collaboration, it's to foster speed in delivery, speed in maintenance, in evolution of products. So teams and tools need to work together. It changes a number of ingredients of the software process, of the software product, of how you architect it, back and forth. Where does TOSCA fit in? Well, behind DevOps, there is one such thing called infrastructure as code. And for some reason, the slide is not behaving correctly, but that's okay. Infrastructure as code simply means that you want to automate whatever is pertinent to actually deploying your product. That's it. So you have, that's what I did. Okay, fine. So it means you have a branch of code that instead of yielding principles or actually parts of the product, it builds up the infrastructure for that product to actually run. And TOSCA is the standard for that. So it's a standard way to actually bring together nodes and edges of an infrastructure in such a way that you can actually structure it. So to give you a very stupid example, you have, this is a web application. TOSCA folks have been using it for like 10 years or so to exemplify TOSCA. It has a number of hosts and an infrastructure. It can be AWS, whatever you have. A series of middleware and the application itself. What TOSCA does for you is provide a standard format to capture all of that in a blueprint. A single graph that references libraries, much like you would be developing software product code, you are developing software infrastructure code. That's what TOSCA does for you. And by the way, thanks Frank for that, because he's actually one of the main inceptors behind it. So where's the problem? So the problem that I faced when I first started fiddling around with this, this was like 2013, and the Trump disaster didn't happen yet. It was nice times, I have to admit. But suppose you want to recommend it to your friends. Suppose you want to say, why TOSCA instead of something else. So suppose you have our Frank, and Frank wants to recommend it to another Frank, which is not as friendly as our Frank. And as it turns out, that is pretty much the same situation that I found myself in. And I'm not sure if any of you has had the pleasure of doing H2020 or FP7 reviews. So that's the average review person in these review meetings that you have to fight for to get your money back. And that was myself, so I started questioning myself against this as well. The key question that came, the key research question would be is, what is the intended design model and programming model behind TOSCA? So suppose you want to use TOSCA, how do you design for TOSCA? How do you actually build a TOSCA representation? Suppose you want to program with TOSCA. How are you supposed to program with it? What are the design principles? What are the programming principles that you are applying? Is there a name for it? Well, because it's Frank, you would assume that he had something to do with it, so probably his background is also into it, and we'll get to that. But why is it important? Well, it is important because if you want to automate it, if you want to use it in action, if you want to build tools for it, if you want to extract patterns for it, you need to know these kinds of details. You need to be able to harness them in practice. And the practitioners that actually built it, they probably know something for it, including Frank. So, how is the design and programming model of TOSCA different than the ones we know already? Let's go in the back, let's take a step back, let's go back in history. Could it be imperative design? I found a lot of pictures of you. Copyright, Franklin, of course. So Frank is involved, so I guess your first go-to is BPM and must have something to do with it. Because it's Frank and it's TOSCA and it's the same person. It has to have some overlap. You would be wrong, as a matter of fact, because imperative design and business process modeling notations don't really fit into TOSCA. TOSCA is a graph of artifacts and strongly typed relations, which also means that the workflow is just a reference. It's just one artifact. It can be passed or not. It can be depending on whatever node you are programming, depending on what kind of blueprint you are actually preparing. So let's take an even backer step. Is it declarative design? For the formalists among you, declarative design includes things like alloy. Carlo Ghezzi from Politecnico di Milano will be very proud for me to actually mention alloy. He's a very big fan of alloy. Or SMV and notations that are functional and reflect lambda calculus, for example. Or goal modeling, that actually is a notation for requirements engineering, but actually reflects also programming languages as well. So more structured constructs. But you would be wrong again. And by the way, yes, so if you're a formalist, then yes, this is your go-to in this case. You would definitely be wrong, but not that much. I would say 50-50 wrong. Because, as a matter of fact, what I found out, thanks to the folks in TOSCA, is that there is a lot of overlap between what they call intent design and what we call goal modeling. So, just to give you a quick recap about what goal modeling is, has any of you heard about goal modeling? How many of you have heard about goal modeling? Okay, I have 2, 3, 4, on the old side, I think. Yeah? And I'm old myself. Right, so goal modeling simply means you are capturing the requirements of a software system from higher order objectives of that system, and then you divide them. You divide and conquer. It's a Dijkstra principle, it's very basic. This is one representation from one of the possible approaches to goal modeling. Of course, here you have functional goals, non-functional goals, and so on and so forth. You can divide this over and over again. The funny and very nice thing about this is that it has formal logic behind it, which also means that if you have a series of requirements as the leaves, you can combine those requirements until you actually fulfill the high-level goal, which is very cool, because you can build your formula and verify your system. That is very cool, to me. So how does TOSCA intent modeling fit into this? Well, TOSCA intent modeling, based on what the folks in TOSCA said to me, is that you model in TOSCA by specifying only the highest order intent goal, and you leave the rest to the orchestrator. What does that mean? What does that imply? Is, as a matter of fact, not clear yet, but we can definitely look into it, and there's reasons to do that. So you model by specifying the highest level goal, regardless of how you want to actually satisfy that goal. So this goes in the blueprint. If you take a TOSCA blueprint, you will find the highest level goal into that blueprint, and whatever relations that blueprint also has. The rest is pretty much left with the orchestrator. So the higher level goal is the only thing you will find in the blueprint. How you satisfy the highest level goal, that's really regardless. It's up to the orchestrator, up to the nodes that the orchestrator can read, up to the open world. So the rest of the orchestrators, the rest of the APIs, which are part of the internet that we know and use. So all of that, the rest of requirements engineering for the system is left to the orchestrator. What does it actually mean from a programming standpoint? It means that you're programming the highest level goal and the rest is empowered in the orchestrator. So the orchestrator is no longer just an executor, it's an intelligent machine. Okay, we're not there yet, but we are getting close enough, I think. And as a matter of fact, Open TOSCA is actually a pretty nice example of that. So what does this mean? What are the properties of this programming model, this design model? Are there any interesting properties to it? I think there are, and one such property is actually substitutability. You have this in your blueprint, that's the highest level goal, and then you have the rest of the topologies, the rest of the services that you are using, they are left to the orchestrator, right? This also means that the orchestrator can decide to change whatever node depending on whatever contextual condition. This is exactly identical to what Wolfgang said this very morning. You can substitute things, so it's not really a big deal. And as a matter of fact, these are some of the intuitive properties that we also figured out with these folks. So substitutability is one of them, and I will also illustrate the others. Is substitutability new? Not really. As a matter of fact, it is not. Wolfgang just spoke of it this morning. But the other ones are actually quite new. So for example, opportunistic hierarchization. So the extracting of a hierarchy based on runtime conditions. And so is the resource-based evolution of this blueprint. Based on whatever resources does the orchestrator have available, then the blueprint itself will actually be recombined. Now these properties have some minor formalization in the paper. There's more to it than this. There's more data that we can also analyze together. So please come and find me if you're interested. More of this, but here's a number of conclusions that I drew very, very quickly. So first of all, if you are designing or implementing your TOSCA, you are carrying out intent modeling, and that changes the way in which you need to think about what is contained in the blueprint and what is assumed in the orchestrator. That also changes the way in which the orchestrator is centric to your research, basically. If you do something in Open TOSCA, it'll be its own thing, but it has to be standard and it can be ported to other orchestrators as well, as long as you reason with this kind of logic. And the several properties, some of them are new, some of them are not, but it definitely needs further experimentation. And that's it.
Okay, wonderful, thank you. Any question or remark? I have a personal remark. It's interesting to learn what I have spoken today this morning.
Thanks.
So now the next speaker is Michael Frankenthal, and he speaks about algebraic properties. I'm very curious for algebraic properties.